Hi, Assalamualaikum warahmatullahi wabarakatuh. To our lecturer, TS Dr. NUZAIMAH BTE Mustafa. My name is Noor Izzah, Bahirah, and our friend is Aiman Iqbal, Noor Amirah, Mohamad Adib Haikal, and Mohamad Iskandar Shah. I would like to present about our topic non-destructive material testing.
Introduction of NDT, dye penetrant testing, which is NDT is the process of inspecting, testing, or evaluating materials, component or discontinuities or differences in characteristic without destroying the serviceability of the part or systems. So the purpose of the NDT is to detect flaws, measure properties such as thickness or hardness, and ensure the safety and quality of products while allowing it to remain in service, which is NDT is non-destructive testing. Alright. So prediction of possible flaws or defects in NDT, which is the first one is porosity. So porosity is a type of defects where small holes or voids are trapped within a material, usually caused by gas entrapment during solidification, welding, or casting processes. These tiny air pockets can weaken the material strength, reduce its density, and lead to leaks or structure failure over time. So detecting porosity with non-destructive testing method like liquid penetrant testing helps ensure the quality and reliability of the final products. So the second one is crack. Because of the stress or leading to a loss of strength and potential failure, some cracks can happen during a non-welding process, such as lamellaring, tearing. So while cracks like hot and cold cracks happen mostly because of welding, crack defects are discontinuities in a material structure.
Selection of suitable NDT method. Number 1. Dye penetrant test. It involves applying a liquid penetrant to the surface of material, revealing surface breaking defect when excess penetrant is removed and developer apply, making flaws visible for inspection. Method number 2 is magnetic particle test. It detects surface and near surface defect in ferromagnetic materials by magnetizing the materials and applying fine magnetic particles which cluster around the defect areas, making them visible for inspection. Consideration of key factor in planning dye penetration tests. Key factor and consideration. Number 1. Material. High speed steel, drill bit. Defect location, drill bit body. Object size 100 mm, body length and 20 diameter. Human skill, university student. And penetrant type is ideal for detecting small cracks or defect. Dye penetration testing procedure. Number 1. Specimen preparation. Cleaning using solvent cleaner. Number 2. Apply dye penetrant to the specimen and air dry. And number 3 is once it dry, apply developer to the specimen, wait until the defect penetrant emerge. Number 4. Inspection and data collection. And number 5 is post cleaning.
For slight evaluation of defect detected, we found two defects. The first one is crack. The size crack is 10 mm. Location of crack from the base is 70 mm from 0 mm. The second is porosity. The size porosity is 3 mm and location porosity from the base 66 mm from 0 mm.
Alright, so we move on to the causes of the detected defects in the drill bit. Firstly, for cracks, continuously drilling into hard materials generates a cyclic axial and torsional loads. Over time, these repeated stresses can initiate surface cracks, especially at high stress areas like the cutting edge. In addition, the friction produced during drilling leads to heat buildup without proper cooling. This heat can cause a thermal fatigue, further contributing to crack formation. Next, we look at the porosity. This defect is often introduced during the manufacturing process, especially the inclusion of gases or contaminants during alloying and forming may become trapped in the metal, creating internal voids or pores within the structure. So we're moving on to potential failure modes and associated risk. For cracks, small surface cracks can grow larger with a repeated use, especially at high rotational speeds. This can eventually cause the drill bit to fracture, resulting in poor drilling performance or even complete tool failure. A fractured drill bit can also shatter during operation, which poses a serious safety risk to the user. As for porosity, it weakens the drill bit by creating internal voids that reduce its structural strength. This makes the bit more likely to deform or break under the load. Additionally, the pores cause inconsistencies in material hardness, which leads to uneven wear. This reduces the efficiency and lifespan of the drill bit.
Next is improvements to prevent defects and alternative materials or processes. For improvements to prevent defects, use proper cooling and lubrication during drilling to reduce heat and avoid thermal cracking. Control drilling speed and feed rate to minimize excessive force that leads to micro cracks. Inspect drill bits regularly using die penetration testing to detect early signs of surface cracks before failure. Store and handle drill bits properly to prevent impact damage and surface contamination. For alternative materials or processes, use high-speed steel with cobalt or carbide tip bits for better heat resistance and durability. Apply surface treatments such as nitriding or titanium coating to increase hardness and cracks resistance. Consider grinding and resharpening worn bits instead of reusing damaged ones. Use precision drilling machines with stable fixture to reduce vibrations and misalignment. Lastly, conclusion. Die penetrant testing is a simple yet highly effective non-destructive method for detecting surface breaking defects such as cracks and porosity. In our analysis, we identified potential causes of these defects and evaluated the risk they pose to component performance. Through careful process control, proper material selection, and regular inspections, these defects can be minimized or prevented entirely. Overall, die penetration test is a valuable tool in ensuring the safety, reliability, and quality of engineering components.